Yes, so the three topics I'm going to cover today are, first one is, what is a design system? Simple answer that's needed to give you this presentation. And secondly, I think the most important thing about design system is the process you have around it. So I'm going to tell you how we have implemented it. And third, since this is a technical meetup, I'm going to talk a little bit about the technical choices we had to make and well, the decisions we made. So first of all, what is a design system? Every time I have to explain a certain concept during a presentation, I go to my good old friend Google and ask him about a short and simple, concise answer to that question. And this time I found an answer written by a guy named Nathan Curtis. And he says, a design system offers a library of visual style, components, and other concerns documented and released by an individual, team, or community as code and design tools so that adopting products can be more efficient and cohesive. This is the shortest explanation he could give, because this is a 10-second explanation. And he has an entire blog post around the subject explaining what it exactly means. But I think this is good enough for now. It's basically a set of tools that can help teams build their products. So why should you use a design system? Well, first of all, it helps you be consistent. All products will use the same design and development standards, so that when you have a date picker component, for example, it will look the same across all products. And it will also work exactly the same for developers, which is something that's really great for users, because recognizability is something that gives them a great user experience. And that's something we're after, of course. Secondly, it really helps you to ship a lot faster. When you use a design system effectively, you don't have to recreate certain parts of your UI. You can just pull them in and implement them really quickly. That way you don't have to focus as much on building your UI, but you can just mix and match and create your application that way. And that brings us to the most important thing, perhaps. It will allow you to build applications with a higher quality, because hard design and development challenges are solved together and in a central place, and they're shared across teams. That brings me to the next point, which is called the Great Divide. A couple weeks ago, oh, that sounds better. A couple weeks ago, a guy named Chris Coyer, who runs the website for CSS Tricks, he wrote an article explaining that there is some kind of great divide going on. And he explains in his article that we're starting to have two camps, basically, within front-end development, where the first camp contains the JS developers, the JavaScript developers, probably most of us here, who are mostly interested in building applications using frameworks. They're worried about state management, things like performance, testing. And the second camp, which is on the other side of the divide, are the UX developers, as he calls them, which are the people who are mostly concerned about HTML, semantics, CSS, building accessible applications and websites. And he basically explains that the front-end development stack, as you may call it, is getting so big and large that it's really hard to be good at everything. And in my opinion, a design system really helps in solving this problem, because when you have a central repository or place where you can build your UI components, everyone can use their own expertise as much as possible. So the developers mostly concerned about UX stuff, about accessibility, can contribute to that repository. And the people building the products can pick and choose what they want from that repository and don't have to worry about writing correct HTML and CSS as much. So that was one of the reasons as well why we created our design system. But before I'm going to show you a little bit more about our design system, I'm going to shortly give you a little bit about the organization structure, at least the online development part. We have 14 teams, 14 Scrum teams, working agile on certain domains of the products that ANWB delivers. So we have some teams working on stuff for vacations, we have teams working on traffic information, and they all build their own products. Every team has their own UX designer, user experience designer, and every team has one or more front-end developers. So it means we have roughly 30 front-end developers in our organization. And those developers maintain together roughly 120 different applications. Those can be really small widgets, those can be larger applications, but that's something they have to maintain and develop. Not all of them are actively being developed, but they're there. So in the early days, we thought, well, it's a great idea to have every team take full, be autonomous so that they can do whatever they want. They have full responsibility, so they can develop their application using their own tech stacks, so they can fully, so they can have all freedom they need. But when a company grows, when teams grow, when products grow, we noticed that sharing stuff between those teams became harder and harder. And that's one of the reasons why we started implementing a design system, so all those teams could work more effectively together. So we created a design system, and every design system has a fancy name. So we called ours Poncho. One of the reasons we called it Poncho is because the ANWB is partly known for yellow raincoats. And a raincoat is a bit dull, and a poncho is super fancy. So we think it's a great name. So what does Poncho, our design system, include? Well, first of all, it contains a lot of documentation, mainly around visual things. So, for example, which colors to use, which typography to use, but also the tone and voice that the application should use. How images should be used, how the logo should be used. And secondly, the thing it contains are the sketch symbols. We have a lot of UX designers who work with Sketch, and Sketch has its own kind of component system, which are symbols. And all UX designers can use those symbols to mock up their applications. And the third important thing it includes is our Preact components. Preact, for those of you who don't know, is something which is basically similar to React. The differences I'm not going to discuss, but on the end, I'm going to talk a little bit about why we chose Preact. The Preact components are available for developers to use. They can mix and match. They can pull them from our internal package manager, and they use them to build their products. So shipping products is something that's really important. We have a lot of applications, like I showed earlier, and we want to build a lot of applications. So I'm going to quickly show you something that we built really recently, which was a new search application. And because we have a solid component system in place, a solid design system, we were able to build this thing in just a single day. And that was because all the UI components were already available. Well, the first component that we had was some kind of structure component, which allowed us to lay out the page effectively. And secondly, we needed an auto-suggest for users to type. And all those components we have available in our internal tool to share those components, which is Storybook. You can see the auto-suggest component on this slide. Probably in the back you can't see exactly what it says, but it provides, Storybook provides a development environment where developers can see how they should use a certain component. It gives information about the props it takes. And it gives a live example which people can tweak live, give different props and see what the outcomes are. It also contains a little bit of code example of how you can use it. So the application also took a button component, as some kind of tab box component with checkboxes, the results, and also a little bit of a bigger component, which was a conversational component, which was built by a different team. They also exposed that thing as a component, so people can put it in their applications to contact some kind of chatbot. And on the bottom of the page, there was a pagination component, which is also used by other teams, of course. So for example, this relatively small application used a different set of components. The ones I showed earlier. And when using these components, we could really quickly build the application, and the only thing left for the team to do was set up API calls and set up state handling. So for example, in this application, the history API had to be used to be able to navigate to certain states. To be able to have those components available to all teams and to have them be updated on a regular basis and to prevent bugs and other mishaps, we need to have a really solid process, how to handle updates and how to distribute them. The first thing that's really important for that is to have a certain amount of ownership. And this is how we handle it within our company. We have a central team, which we call the platform team. Well, we don't call it a platform team, but it is a platform team. And that team holds ownership over the tooling. They're responsible for making sure the Storybook instances running. They're responsible for distributing the packages, and they're responsible for the sketch components that they're updated and distributed correctly. But all the other things we do together. So for example, the designs are done by all designers together, they're reviewed together, and are accepted or declined together. Same with code changes. Everyone can change code in the central repository, which contains all the components. And they just have to, they can make changes. They only have to send in a pull request to the platform team. So all in all, it's a shared responsibility so that everyone is allowed to make changes, everyone can make changes, and everyone can take responsibility, which helps them to use the system as well. And another thing, that's the source of truth. With design systems, it's often a really hard choice where you put the source of truth. There are basically two options. Either you say, well, all the designs are the source of truth, and the components are to be developed based on the designs. Or you can say, well, the really working component is the source of truth, and we need to sync the design in some way. There are certain tools to help you manage that, like there are tools that can take React components and generate sketch files, for example. But in our company, we decided that the designers were always the one making changes to components. They're making iterations, they're discussing new features. So we decided that the source of truth should be the visual design of the component. And every time a change is made, a developer has to pick that up and put it into the Preact components. So we think of our design system as an actual product that's being worked on. But one thing we have to make sure of is that the adaption is good, because everyone needs to use it. we would like everyone to use it. So we need to motivate people to use it. And the most important thing regarding that is the ease of use. Using Poncho should be easier for a team than not using it. If they're building something, they should be a lot quicker with using those predefined components than building them their own. We implied a certain amount of dogfooding. The team that originally started the design system was also a team that had some products, and that team started building their products using that design system so they could easily track changes and find out problems early on. And another aspect that's really important if you have a design system is that there's a lot of communication. That's why we have weekly meetings where people share changes made in the components and all changes made in the designs. Another thing we have is we have a certain amount of guidelines in place on how to handle changes or on components or on creating new components, because that's also a really hard thing to handle. The first thing that a team has to do when they want to change is they have to write a proposal and create a visual design accompanying that proposal. And they have to run it by their peer group. So in most cases, it's a designer who has a certain need for a certain component or a change on a component, and they make a proposal. The second thing I have to do, and this is, I think, is the most important thing in our design system, is that they have to do some kind of validation. They have to use some kind of testing to make sure that the change they're proposing is actually something that the end user will benefit. So for example, they have to run an A/B test, or they have to do some kind of other kind of testing. We have, for example, a test lab where we can invite people to use products and to see if it works. And these steps make sure that not everyone puts in changes just because their taste is different, but all changes are actually an improvement. When it has proven that it's an actual improvement, the third step will be that the team which made the suggestion for the change is also going to develop it. That means that we don't have a central team developing all components, but all development is spread across the teams. This makes sure that we don't have a bottleneck somewhere, but that everyone can just continue with their work. The development, when done, will be finished with a pull request, which will be reviewed, and when deemed successfully, it will be released. So the sketch symbol will be updated and the components will be bumped to a new version, either a minor or a major version or just a patch. And the last step again is to tell about it, show it, make sure that your peer group knows that a change has happened. So some statistics on the usage within our company. We started, I think, roughly a year ago, and we now have 78 different components in use. And they're used by 35 different applications. So it's getting a nice start, I think. So that brings me to the final part, some of the technical choices we made along the way. Well, the first one is Preact. And this is a React meetup, so I have to explain myself. Well, when we first started with the design system, we decided on React. I think that was late 2017. And at that time, Preact and React were exactly the same, except for the bundle size. Preact is quite a lot smaller than React is. So, well, when we first proposed this React component library to each other, there were some people who said, well, have you heard about this thing called Preact? It's just smaller. Maybe we should have a go with that. And we thought, well, let's try it out. Let's see how far we can go. And if we run into something, we might be able to switch. The great thing is that the APIs are almost exactly the same, so switching isn't that much of a burden. The thing with Preact is that it's really familiar. React is the most popular UI component library out there, so new people coming into the company can really quickly get up to speed. And like I said, Preact is somewhat smaller than React is, which is not really noticeable for developers in the sense that they're missing certain APIs, but I hope it's noticeable for the end user, because there you don't have to download as much JavaScript. But when we look at the future, into 2017, the differences weren't really that noticeable, but nowadays the React team is bringing out lots of new features with asynchronous things and hooks, and they have a whole dedicated team working on this. And with Preact, it's a little bit harder. It's a pure open source project with people voluntarily working on it. They have promised some new features in Preact X, which should be released the first quarter of this year. So I hope it gets out really soon. But it does make us wonder if maybe we should switch to React, because of all the features that are already available there, and Preact is, well, it's always going to be a little bit behind. Another thing that you need to consider when building a component library is whether to implement individual versioning. You can basically go two ways. You can either say we have a component library, which is a single package, which contains all the components and just has one version. Or you can set up a system that individually versions every single component with its own package JSON and its own version numbers. We decided on the second one, sorry. And the reason why we did that is that it gave us a lot more of a flexible upgrade path for teams building their products. A breaking change is something that isn't going to really stop you, because you can choose to update certain packages and leave others for later. And having that flexibility always also allows the teams working on the components to introduce breaking changes more easily, because it's not going to have that much of an impact. The thing that did make it really hard is that we noticed that teams aren't really updating their components as quickly as we would like to. Like most of you know, running Yarn Upgrade Interactive or any other way to update your packages isn't really done a lot. So we noticed that a lot of applications were really lagging behind with versioning. So that's something that we also have to look at and see if we can get something in place, some tooling to help teams upgrade. Another thing is quality assurance. When you have that much components and when they're a central part of your UI development, you have to make sure that you're not introducing bugs. Storybook is really great in helping you with testing components. For example, they really easily allow you to render every component in every possible state. And we use that together with snapshot testing, so that we store the HTML output of our components together with the component itself. So we can easily detect when there are changes to the rendered HTML. Something that we also have in place is analytics and error monitoring. Like I said, in our process, we think it's really important that when proposing changes, people really need to look that the components or the changes they make are going to make an impact, a positive impact. So that also means that we are using analytics to actively track whether components are being used the way they should be. Oops. Everything okay? Great. And also another thing that is error monitoring. We have runtime error monitoring set up, so we can easily and quickly detect when we introduce bugs in production. Another thing that we're not yet using are screenshots. Storybook makes it possible to have all your components rendered in headless Chrome, screenshots made of that and stored with the components itself, but it's just something that we haven't gotten around to implementing yet. And as for the last slide, I have some small specifics. We had to make a choice about CSS and JS, which is also a really hot topic. But the thing we had is that most of our developers are really eager to use it. The thing that's holding us back, sadly, is that we also have a CMS which renders, pre-renders our content pages, and we want to be able to reuse the styling in our components used by our front-end applications. We want to reuse that styling with our CMS output, which meant that we just had to use class names. So for now, we're just fine with our CSS files. Another thing, new features like hooks and other fancy additions is something that we're not really reluctant to try quickly, because like I said, the most important thing is that it's easy to use and that people are familiar with it. So we try to wait as long as possible with introducing new concepts. And lastly, TypeScript. We're currently using Flow, and a lot of people are really happy about it. But we noticed that in the community as a whole, TypeScript is a lot more popular, and overall usage, developer usage statistics are a lot better. So it's something that we're considering switching to. But I don't think that's going to have a lot of impact. Well, that's basically it, what I wanted to talk to you about today.